Hey, I hope all is well, and here we go. We're going to factor completely. We're really working on sum and difference of cubes over here, but the challenge is that we probably learned our perfect squares before it, and we want to stop maybe one common mistake from happening when we move over to work on sum and difference of cubes. All right, let's get into it. Let's go back to what we maybe know from before, perfect square trinomials. Now we'll notice that 4x and 9 are perfect squares. 12 is not a perfect square, but let's go ahead and do the square root of 4x squared, which is 2x. And what's the square root of 9? All right, plus 3 and plus 3. Now let's go ahead and FOIL this out. Now you could also write it as 2x plus 3 to the second power, which is equivalent to this. And your teacher might say FOIL or double distribute. And here we go. We'll get 4x squared plus 6x. Distribute those. The 3 goes to both of these, so plus 6x plus 9. And that gives us 4x squared plus 12x plus 9. And that's what we started with, so that lets us know that we still got at the 12 because the outer and the inner of FOIL, those are the ones that blend together and make the middle term of the trinomial. Now here's where we get into trouble. The rule for sum and difference of cubes is A, and then we're going to have something here, plus or minus, and then B. A squared, B squared, but there's not a 2 in here. Do you notice how the middle doubles here? Some teachers might say it's A squared. I'm running out of room here. It's A squared, 2AB, B squared. This is always positive. Now if the problem was a plus, an addition problem, we would have that right there if it was an addition. But if it was a subtraction problem, we'd have a minus there. And so what happens on squares, you'll notice that the middle gets doubled. And so what happens is, I've noticed that students will sometimes carry over this 2AB over to here, and that's not a 2AB on cubes. Cubes is just an AB. And so here's our formula for our setup to factor sum and difference of cubes. Now you might see in your textbook or in notes something that looks like this, which seems kind of intimidating, but what it's saying is the sign for this first one, whatever it is, it should be the same. Then the sign, the connector to AB, should always be opposite. And then the last one's always plus, so sometimes we'll hear teachers say always positive. So same, opposite, always positive, and the way that we can remember that is SOAP. But you really have to know your A's and the B's before you can kind of just worry about signs. And the big one is understanding that that's a 2AB, and when you're doing cubes, it's just a regular AB. All right, so let's head over here. We still need an A, which is going to be the cube root of the first term, x cubed, and B is going to be the cube root of the second term, which is 125. And if it was minus, we wouldn't worry about the signs because it's taken care of in our little format here. So the cube root of x cubed is x. The cube root of 125 is 5. And now we're ready to go. So this gives us x for A. And in the place of B, we're going to put what? Good, 5. Our sign should be the same, plus. Now we got to do A squared. And go ahead and say it out loud. What's x times x? Good, that's x squared. And then what's A times B? 5x. And then the last one, what's B squared? 5 multiplied by 5, which of course is 25. So this will be minus, and this will be plus because it's opposite and always positive of what the original problem had. Now, there are some students that think that this can factor a little bit more. Well, let's try it. X multiplied by x, especially given where we were here before. This is x multiplied by x, and what multiplied by what makes 25? Okay, 5. And look at the sign in the middle. Let's try it out. Let's go ahead and check it with a FOIL or double distribution. X minus 5x minus 5x plus 25. And does that match? That was actually x squared. Does that match? And the answer is no. This portion right here, after you do a sum and difference of cubes, unless you missed a GCF, will not factor. It's going to be kind of an interesting thing later when you move down to quadratics. This portion is going to yield some imaginary results. Okay, so I wanted to kind of highlight for this one, really it's a compare and contrast between maybe what you have worked on before with perfect squares over compared to trinomials, sum and difference of cubes. I'm going to go ahead and clean up the board, and let's just do one more problem, sum and difference of cubes, and we'll take it coast to coast here pretty quickly.